Yes, hello everyone, welcome back to our channel students. So in this video we are going to talk about a new unit called P block elements. Clear? So P block elements is one of the very important and very big chapter in your syllabus. So according to Karnataka PU board, the P block elements has the weightage of 10 marks. 10 marks, and there will be one question of 1 mark and there will be 3 more questions of 3 marks each. So the total weightage is 10 marks. So in this chapter, we are going to talk about the first. Initially, we will take the introduction to P block elements, and then we will be talking about group 15, 16, 17, and 18 elements. Generally, P block means that group 13 to group 18 elements we call it as P block. But in first year PUC itself, we have studied regarding group 13 and group 14 elements. So in this unit, we are going to talk about 15 to 18 group elements. Clear? So and then the preparation properties and uses of some important dinitrogen, phosphorus, oxygen, and ozone. And later we'll be talking about the electrophilic forms of sulfur. And then we'll be talking about the preparation properties and uses of chlorine and hydrochloric acid. Clear? So and we have halogens and structure of oxo acids of halogens itself. And finally, we will end up with the uses of noble gases. That means the 18 group elements. Clear? So halogens, 17 group elements are known as halogens, and 18 group elements are known as noble gases. Clear? So now let us take the introduction to P block elements. So coming to the introduction to P block elements, what are P block elements? For those elements, we call it as P block elements. For which elements? So P block elements are the elements in which the last electron enters the outermost p orbital. Clear? So those elements in which the last electron enters the outermost p orbital, we call it as P block elements. Clear? For example, from group 13 to group 18 elements are P block elements, but there is one exception, that is helium is an exception. Why it is so? So helium, you have observed your periodic table. Helium comes under our 18th group. Clear? So 18th group we have considered it as P block element. So it is a noble gas, helium. But coming to its electronic configuration, if we take this definition, that means when the last electron enters the outermost p orbital, helium is an exception because helium, the atomic number is 2, so the electronic configuration is 1s2. Clear? So in this case, the outermost electron is in the s orbital, although it is placed in group P block elements because it is placed in 18th group. It is because the properties of helium resembles the properties of 18th group element, that is noble gases. Helium is a noble gases. So although if this definition is right for P block elements, we have an exception in case of helium because of its properties. Although the last electron enters its orbital also, helium is considered as helium, it is taken as P block element, but still the discussion is going on for this case, helium, whether helium to group on S block or P block, but for the time being, we are considering helium as P block element. Clear? So this is the general introduction of P block elements. Now let us look at the properties of P block elements. Coming to the properties of P block elements, now let us look at the electronic configuration, that is general electronic configuration of P block element. It is ns2np126. Clear? So s orbital is completely filled and ns2np126. ns2np1 for 13th group, np2 for 14, and like that np6 for 18th group elements. Clear? So that is the general electronic configuration. In P block we have metals, non-metals, and also metalloids. Yeah. So metals and non-metals you know about it, but metalloids is a new term for you. Are metalloids means these are intermediate between the metals and non-metals. Clear? These metalloids have the property of both metals and non-metals also. So in P block we have all these, that is metals, non-metals and metalloids also. Clear? So these P block elements we have numerous applications also in this case. Clear? So the valential electronic configuration and all. Coming to the oxidation state, general oxidation states. So we are focusing on 13, 14, 15, 16, 17 and 18 group. Clear? So which is headed by boron, carbon, nitrogen, oxygen, fluorine and neon. Clear? So coming to the oxidation state, in our previous video we have discussed regarding the semiconductors. There we have taken one 14 group element, that is a semiconductor, that is silicon, and we have even looked with 15 group and 13 group also. So in that the oxidation state of this is generally +5, clear, and this is +4 and this is +3, clear, generally, but as you go down the group it varies. So general oxidation state resembles the group name, clear. So that is regarding the oxidation state. Whereas if you go down the group, the oxidation states varies during that we refer that we will discuss in the upcoming classes. So the next important thing in case of okay, so the next property of the P block elements is the first member of the group. For example, we have in 15 group we have nitrogen, that is the first member, and it is followed by the other elements. See, we call it as the nitrogen family for this. And for 16 group we call it as oxygen family. It is because it is headed by nitrogen and oxygen respectively. So here, so we will give the family names based on the first element. So, but if you focus on the properties of the whole group elements and that of the first one, there are some very different properties as of the first group and then of the other elements. Clear? That we call it as anomalous behavior. Anomalous behavior. Even you have discussed the anomalous behavior of boron and carbon in your previous year also, and in this year we are going to learn about the anomalous properties of this. That means the nitrogen has a different property than rest of the elements in 15. Clear? So we'll talk about that. This is regarding the general properties of P block elements. And now let us focus on group 15 elements. In group 15 elements, it is known as nitrogen family, or it's also known as nicogens. P is silent here. Why it is? Because the elements which are headed by nitrogen, we call it as nicogens here. So nicogens are the elements of group 15 which are headed by nitrogen, we call it as nicogens. In group 15 elements we have nitrogen, we have P phosphorus, arsenic, antimony and bismuth. Here we will be dealing with these 5 elements in group 15, that is nitrogen, phosphorus, arsenic, antimony and bismuth. So coming to its metallic properties, nitrogen and phosphorus are non-metals. Here nitrogen and phosphorus are non-metals, whereas arsenic and bismuth, arsenic and antimony arsenic and antimony are metalloids, and bismuth is a pure metal. Bismuth is a pure metal. That means group 15 elements contains all the three types of substances. That means they have non-metals, they have metalloids, and they have metals. Clear? Metalloids means they are intermediate between metals and non-metals. They do have property of metal also, and they do also have a property of non-metals also. Clear? So the general oxidation state is general oxidation state is +5 generally, and also we have -3 and +3. This variation of oxidation of +3 is due to the inert pair effect. Inert pair effect you have studied in the previous years. Clear? So that variation is because of inert pair effect. Inert pair effect. Clear? So the current general electronic configuration. General electronic configuration of 15 group elements is NS2 and NP3. Clear? So if you observe this NS2, NP3, S orbital is completely filled. S orbital is completely filled, whereas P orbital is half filled. So there is extra stability in 15 group elements because of completely filled S orbital and half filled P orbital. Clear? So whereas 18 group elements are completely stable, they are highly stable. Why it is? It is because the general electronic configuration is NS2 NP6. That means S orbital is also completely filled and P orbital is also completely filled. So and the next, these 15 group elements have some extra stability when we compare to 13, 14, 16 and 17 group elements. Why it is? It is because of the half-filled P orbital. Clear? So P orbital can accommodate 6 electrons. Clear? So in that we have. Now this is so you can have 6 electrons where in case of 15 group elements only the 3 electrons are free. That means this is half, so it is having extra stability. Yeah. So these are the general properties of 15 group elements. Now let us look at the occurrence of 15 group elements. Coming to occurrence, the first one is nitrogen. Yeah. So where do you get nitrogen? It is very simple that our air consists 78% of nitrogen. Yeah. So atmospheric air has 78% of dinitrogen. It is in the form of molecular nitrogen, or also we call it as dinitrogen. This is molecular nitrogen. Here, so atmospheric air has 78% of dinitrogen by volume. And next thing, you find nitrogen in sodium nitrate and potassium nitrate in earth crust. Yeah. So these are the two major things where you get nitrogen. One is atmospheric air, and one more is sodium nitrate and potassium nitrate in earth crust. And even coming to phosphorus now, where do you find phosphorus? Phosphorus are present in animal bones, milk, eggs you have. Yeah. So if you have a weaker bone, doctor will advise to take more phosphorus because phosphorus are present in animal bones and milk and eggs also here. And next we have arsenic, antimony and bismuth. These three are found in sulfide ores. Yeah. So these three are found in sulfide. So these are the occurrence of 15 group elements. And we have in case of phosphorus also, it is also found in phosphate rocks. Phosphate rocks also, clear? So now let us focus on yes, students, I have said you that nitrogen shows anomalous behavior. That means nitrogen's behavior is different when you compare to the other elements in that particular group. Now let us see what are the reasons for that, why nitrogen shows anomalous behavior and what are those different behaviors. That means what are the anomalous behaviors of nitrogen. Clear? So first of all, let us look at the reasons for that. Why nitrogen behaves different other than that of the other elements. It is because see, nitrogen is the first element of the 18th group. Clear? So, atomic size is very less. Atomic size is very less. We have already discussed, we have already studied this. As we go down the group, let me write it. Nitrogen, phosphorus, arsenic, antimony, and bismuth. Clear? This is a group, a vertical columns, we call it as group. So, as we go down the group, atomic size increases because the number of shells increases, there will be addition of new shells as we go down the group, so atomic size increases. So the nitrogen is the element with the smallest atomic size. So as the atomic size is less, what about ionization, enthalpy, and electronegativity? Ionization enthalpy will be known. What is ionization enthalpy? The minimum energy which is required to remove the outermost electron from its atom. Clear? So, as the atomic size is less, if we have only one shell, there will be the force of attraction between the nucleus and the outermost electron will be more. That means nucleus will have a strong hold on the electron. So it is we need high energy, we need maximum energy in order to remove this electron from the influence of its nucleus. So as the size is less, as the size decreases, the ionization enthalpy increases. This is the main reason. These are the two main reasons for the anomalous behaviors of nitrogen. Clear? And also the electronegativity, it is the capacity to attract the shared pair of electrons towards itself. In that case, nitrogen is having more electronegativity. That means it has the more capacity to attract the shared pair of electrons towards itself. It is more dominant. Clear? So nitrogen, and the last fourth point is the absence of the orbital in case of nitrogen. Example, we focus on the electronic configuration of nitrogen. It is 1s2, 2s2 and 2p3. Yeah? So there are no d orbitals, there are only s orbital and p orbital. So the absence of d orbitals also plays a major role in the anomalous behavior of nitrogen. And the fifth one is it has the capacity to only form p pi bond with itself. Yeah? Because it cannot form p pi and d pi bonds because there is no d orbitals. So the only possibility is it can form only p pi bonds. So these are the 5 important reasons. This question is important. Reasons for the anomalous behavior. So these are the 5 reasons for the anomalous behavior of nitrogen. One is the smaller inside, why it is smaller? Because the only one shell is there, only 2 shells are there, one first and the second one, so the atomic size is very less. And so as the atomic size is less, there is high ionization enthalpy and because of high electronegativity, and there is absence of d orbitals and the capacity to form p pi bond with itself. Here it cannot form d pi bonds because of the absence of d orbitals. So now let us see what are the anomalous behaviors. What are the different behaviors of nitrogen other than the rest of the elements? The first one is nitrogen is a gas. We know that atmospheric air consists of 78% of nitrogen by volume. Clear? So nitrogen is a gas while all other elements are solids. Clear? Phosphorus is a solid. Phosphorus, arsenic, antimony, bismuth, they are solids. But whereas nitrogen is a gas, that's a different behavior. And second one is nitrogen is diatomic. It exists in the form of molecular nitrogen R92, that is diatomic. But whereas all others are polyatomic. For example, phosphorus exists in the form of P4. Clear? So it is polyatomic. So the third one is nitrogen can form bonds with only 2 pi bonds. I have studied about the diesel system because there is absence of the orbitals. And the last one is it is less reactive due to triple bond because nitrogen it exists as a triple bond. Yeah, in diatomic, in molecular nitrogen, it exists as a triple bond in nitrogen. So it is very hard to break these 3 bonds. Whereas all other elements, for example, phosphorus, it exists as a single bond, and whereas even the arsenic also exists as a single bond, and bismuth, antimony also exists as a single bond. So it is very easy to break these bonds because there is only single bond. Whereas in case of nitrogen, we need more energy to break the bond. So this is less reactive because of the presence of triple bond. So these are the anomalous behaviors of nitrogen. Yes, now let us talk about the reactivity of these group 15 elements. How do these group 15 elements react when they are reacted with hydrogen, and how do they react with oxygen? Clear? So when these group 15 elements are treated with hydrogen, generally they form trihydrates, respective trihydrates. Clear? So in the form of EH3 is represent the 15th group element. So stability of these trihydrates, 15th group trihydrate decreases due to the decrease in bond dissociation energy. It means that as we go down the group, that means NH3 it forms PH3, arsenic H3. Yeah. So it means that as we go down the group, the stability of these hydrides decreases. Why it is so? It is because as we go down the group, the bond dissociation energy decreases. It is because as we go down the group, the bond strength decreases, so bond dissociation energy decreases. So it is very easy to break the bond. Yeah? So the stability decreases. So if a chemical bond is easily broken, means that particular compound is not stable. It can react with any other element. So as we go down the group, the bond dissociation energy decreases, so stability of these trihydrates decreases. It means that this NH3 is the most stable one, whereas this BISH3 it is the least stable one. Why it is? Because of this bismuth hydride is having lowest bond dissociation energy. Clear? And the next one is the reducing power increases down the group. It can be easily reduced. So this reducing power, as we go down the group, it increases. So this is regarding the reaction of group 15 elements with hydrogen. And when we look at with oxygen, when these group 15 elements are treated with oxygen, they form trioxides and pentaoxides in the form of E2O3 and E2O5. Clear? So whereas pentaoxides are more stable than that of trioxides. These are the results that we get when the group 15 elements are reacted with hydrogen and oxygen. Now we have one simple concept. Clear? So pH3 is having lower boiling point, a lower melting point than NH3. Clear? Why it is so? pH3 is having lower boiling point than that of NH3. It is because when it absorbs NH3, it forms intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Why it is? Because the hydrogen can form intermolecular hydrogen bonding with any electronegative element. Clear? So nitrogen is some more electronegative element. So nitrogen, this is the structure of NH3. This hydrogen can form intermolecular hydrogen bond with this of nitrogen because nitrogen is electronegative. Clear? This is more electronegative. So this hydrogen can form the hydrogen bond. So the bond, there will be some bonding. So it is nitro NH3 is having more melting point. Here, so it is very hard to break. Whereas PH3, there will be no intermolecular hydrogen bonding. No. It cannot form. This hydrogen cannot form hydrogen bonding with another phosphorus. So this is the reason why NH3 has more boiling point than that of PH3. Clear? So now let us stop, and up to this point we will discuss regarding next thing in the coming video. Thank you, students.